enable disk caching on our virtual machine. Let's head over to the Azure portal. Okay, here we are in the Azure portal, and let's go to our virtual machine, SLVM02. This is the machine that we created the extra virtual disk on previously. If we head over to disks, we should see we have our OS disk and a data disk there as well. And if you look below, you can see that host caching is currently set to none. Now there's no option currently in this area to change the host caching, so we need to head over to PowerShell. The first thing we need to do in PowerShell is store our VM as a variable. And to do that, we'll need two things, the name of the VM and the name of the resource group that it's in. If you're unsure, just type in get Azure RM VM. And this will list all of your virtual machines and their associated resource groups. As you can see, we have two virtual machines here, both in the resource group SL70533-VMs. So we'll go ahead and store that VM in a variable. $VM, that's our variable. Get Azure RM VM again. The resource group name, followed by the name of the virtual machine. Okay, if successful, you won't see anything, but you can validate that everything is stored in the variable by just type in $VM, and we can see that our virtual machine is there. At this point, you can also see a property there called storage profile at the bottom, and inside of that, it contains our image reference, OS disk, and data disks. If we want to access the data disk, simply hit $VM to reference our variable, period, storage profile, period, data disks. This will then list all of the data disks associated with our VM, and in this case we can see our data disk called SLVM02 disk 2, our disk size of 2000 gig, and more specifically what we're focused on here is the caching, which is currently set to none. So now we need to set the caching to read only or read write. In our case we're going to choose read write caching, so we type in set Azure RM VM data disk, the VM variable that we created earlier, the name of the data disk we want to reference, in this case SLVM02 disk 2, followed by the caching mode we wish to choose. So in this case we mentioned we'll use read-write caching. And finally we need to update the Azure RM VM with this configuration, so we pipe all of that to update Azure RM. Hit enter, and after about 30 seconds you should get a response that says success true. Now let's go over to the portal and validate that disk caching is now set to read-write on that data disk. And as we can immediately see in the bottom right, host caching is now set to read-write. And that concludes this demonstration. In this demonstration, we're going to take a review of Azure VM networking, and you've seen the constructs come up over and over throughout the course already in different pieces. But now let's just take a look in the Azure portal at some of the networking constructs that you just need to make sure we reinforce and you're familiar with. So in the Azure portal, I've got a virtual machine up here, SL-VM01. And first of all, I'm just going to go straight over to settings to networking and bring all of this up for us. So first thing to note is you can attach a network interface and detach a network interface from here. So we have this interface attached, SL-VM01215, and you can, build additional NICs. You can go and create a resource, and you can do a network interface directly from here. You can see it there. We can create one. And you decide when you create this interface what virtual network it goes on, what subnet it goes on, private IP address can be dynamic, static, all the things that we're going to kind of review as we go back through that VM. But just be aware again that the NIC is a separate interface card that can be attached to the virtual machine and detached as needed. So let's go back over to the machine. I'm not going to build another interface now. We've already got one on there. So back to the VM. And we can see the interface, and just below that you can see we've got the network security groups, and we've got inbound port rules and outbound port rules. And again, this is if we've got a network security group that we want to attach to the interface itself, or potentially on the subnet. So you can see we've got a network security group, and it says impacts 0 subnets, 1 network interfaces. So again, just know that, because this is a place where you can check the effective rules you have against your machine. Now if we go back up and click the NIC card itself, we'll click this one here. This will take us into the interface, And a few things you'll notice straight away. One, you've got your private IP address here that was allocated by DHCP, but we also have our public IP address, which is also clickable. We're not going to go into it just yet, but the public IP address is, allocated to us and is also something that you can build on demand. It's like a separate service in itself that is attached to the NIC. So again, the NIC's attached to the VM, but we can attach a public IP address to the NIC. And let's go to IP configurations. This is where we do all of our IP addressing. And you can see in here, we've got IP forwarding, which we can disable or enable, the virtual network, which we can go to if we want to click on the network and do some network configuration, and then the subnet that we're basically in here as well. So in this case, we're in this default subnet 10.1.1.0/24. But on the bottom, you can see we've got IP configuration. So if we click this IP configuration, this is where we decide, okay, am I going to enable the public IP address or disable the public IP? Which public IP address do I want to use? I can click this link here. This will take me to, choose public IP address, or I can create a new one directly in here. So again, I can create that as a service by itself, or I can create it directly from within the IP config pane in this case. But that's how we associate the public IP address with the NIC. Below that, I've got my private IP address set in. So you can see I've got my virtual network subnet link available to me here. You can see it's dynamic. It's allocated by DHCP 10.1.1.4 was allocated to the machine. And if I want to make that static, I can click static. That's basically going to put that DHCP reservation in Azure under the covers that makes sure that this machine is always going to get the 10.1.1.4 IP address. So let's close this out. We'll go back to the networking section and go back into that NIC card. And you can also see we have our DNS server section here as well. And this is where we can inherit from the virtual network. So we can set DNS settings up on the virtual network itself, or we can choose custom. So if I want this machine to utilize a different DNS server, I can essentially do that here. So not too much in this section. Most of the time you're going to do this from the virtual network itself, but there might be an occasion where you want to specifically, call something out for a specific virtual machine. And last but not least, we're going to go to network security group again. I'm not going to make any changes there. Click the network security group. This takes us into it, and we can click inbound security rules here on the left hand side. So now again, we're looking at it from the NSG perspective. I could simply wipe out those rules by clicking these are the default rules, I should say. We can simply wipe those out by clicking this here. I can add more rules. I can change the rules. They're all here. These are the defaults that we discuss in the networking section. Same for outbound. If I go to network interfaces, I can see that this NSG is applied to that SLVM 01215 network interface, and it shows me there that that interface has that public IP address we just talked about and the private IP address. Yeah. So the key thing to think about in Azure is, when you're dealing maybe historically with a VMware environment, you go into a VM, you see your NIC and everything's kind of there, and you also have like a distributed virtual port group that you might look at as well. But in Azure, think about everything is kind of its own construct. The public IP is a construct in Azure that I can buy and reserve. The NIC is a construct, the VM itself is a construct, the subnet is a construct, and all these things are software defined, and I'm essentially piecing them together. So there's different viewpoints that I'll see depending on if I'm looking directly at the NSG or if I'm looking at the virtual machine or the NIC, etc. So just helps, hopefully that makes it clear for you. But I definitely encourage you to kind of just explore the section, take 5 minutes, detach a NIC, attach it back on, try to go to a static IP, try to go back to a dynamic IP, just work through all those scenarios, and that'll give you some good background, in terms of how you do things. And in particular on the NIC card piece, definitely just not only detach it, but completely remove it, delete it, and then add another one to the machine, and you'll see some of the things that you run into as you do that, because things are in use and you can't delete them, etc. So with that concludes this demonstration, but definitely let us know if you have any questions at all. Okay, so we know we need to plan for availability in Azure. How do we go about doing that? And the mechanism Microsoft uses for that are availability sets. Before we can kind of decide how to use them, let's understand our potential for VM impact first. First of all, we have planned maintenance. This is when Microsoft needs to patch or say do some firmware upgrades on the underlying hardware that your VM is running on, and they need to evacuate your VM. In most cases, this will happen using their live migration technology. They'll simply move your virtual machine from one host to another. But on other occasions, they do need to shut down your virtual machine in order to do this maintenance because live migration won't work for whatever reason, and so you need to account for that. The second one is unplanned hardware maintenance. This is when Microsoft detects, using say their monitoring systems, that a failure may be about to occur on the underlying host. And again, kind of like planned maintenance, they need to move your virtual machine, or sometimes very quickly they have to shut all the virtual machines down, do the maintenance, and then bring that host back up. And then finally, we have unexpected downtime. This is when there's a catastrophic failure to the underlying hardware, and you're essentially forced. Your VM is shut down immediately, not gracefully, and the VM will eventually be powered on another machine, but your application will receive an outage. The way to solve this is using availability sets. This allows us to group two or more machines into a set, and they're basically separated out based on two things, fault domains and update domains. If we think of fault domains, first of all, this is essentially when we have a rack that has its own power, its own networking connectivity, and we can have up to 3 fault domains in an availability set. So if we think of our virtual machines, if we have 3 virtual machines in a particular tier, which we'll get into more in a moment, they can be spread out amongst those fault domains if we've used 3 fault domains. If there's an outage to one, the virtual machines on the other fault domains will be unaffected, and eventually the virtual machine that had the outage on the first fault domain would come back up once Microsoft resolves the underlying issue, or just simply moves your machine to another host. In addition, we have update domains. So think of these a little bit differently. Microsoft has to patch a whole series of hosts, but they will do them sequentially, and they won't patch the same update domains at the same time. Now, they allow you up to 20 update domains, so your virtual machines will be spread out amongst those update domains in your availability set. You don't control the specific order. So for example, if you've got 3 update domains, UD0, UD1, UD2, we know that they won't happen at the same time. Again, this is the patching of the underlying hosts, not your virtual machine patches themselves, but we know that UD0 won't happen at the same time as UD2, but UD2 could happen before UD0. This isn't an ordering system, it's simply a separation. If we think of planning for availability in a little bit more detail, the other thing we need to think about is what goes into an availability set. Well, it's very important that you put your tiers into separate availability sets. Think of it like this. We would have an availability set for our web tier, an availability set for our app tier, and an availability set for our data tier. Now think of it just from a fault domain perspective. We know now in our web tier that if we had 3 fault domains, those 3 servers would be separated out between 3 underlying fault domains. The reason for this is if we combined everything, let's say we put our data tier and our app tier and our web tier all together, we could be in a situation where all of our data VMs are on the same fault domain, because again, we've only got 3 fault domains. Microsoft's going to spread all of those machines out amongst the fault domains and update domains as well, obviously. And, if we've got too much in there grouped together, they could just, we could just have all of our data machines on the same fault domain, and that doesn't really help us from an availability standpoint. So use this model whenever you're trying to decide, what availability sets to use. And there's definitely a lot of questions, at least when I did the exam on this. They'll give you some scenarios on, he has so many web servers, so many app servers, so many data servers. They'll describe the scenario, and you have to decide how you group the servers out. Okay, so in this demonstration, we are going to now create an availability set that we can place 2 virtual machines in. Let's head over to the Azure portal to begin. In the Azure portal, the first thing we need to do is head over to availability sets. You can use the search button at the top, type in availability, and you'll see the services appear for availability sets. I've already selected that here. So if we go ahead, let's create our first availability set. Click Create Availability Sets at the bottom, or click the Add button in the top left. In there, you'll need to type in a name for your availability set. So in my case, I'm just going to use SLVM Demo AS. We'll choose our subscription, and we'll use our existing resource group or create a new one if you feel the need. In addition, we choose our location, and then you can see here, we've talked about it in the PowerPoint presentation. We've got a number of fault domains and update domains I can use. So I can go up to 3 fault domains. In my case, I'm going to choose 2 right now, and I can choose up to 20 update domains. And again, this is how our VMs will be spread out inside the availability set. Next, we have this option around manage disks. If we use manage disks and say yes aligned, Microsoft is going to make sure that our disks underneath the virtual machine are also appropriately put into availability sets. There's nothing we need to manage manually there, as opposed to when we do it in kind of the classic methods. So with that said, just go ahead and click create, and your availability set within a minute or so will be ready for you. And now it's ready. We go to our resource. We can see our availability set here. We can see our fault domains, update domains, and currently we have 0 virtual machines in there. So let's go ahead and add a couple of virtual machines. And to do that, it's really the same as creating a new virtual machine as we did in one of the earlier modules. So we'll just go ahead and click new and get into the virtual machine creation here. Give it a name, etc. So in my case, I'm calling this SL Test AS for availability set 01. Give it a username, password, etc. Choose your subscription and resource group. Select your size. And then you can see here, when you get to the high availability section of creating the virtual machine, simply expand this out, and you can choose your availability set. We can actually create a new one directly from here in virtual machine creation, but go ahead and select your availability set there, and now it knows that this virtual machine, when it's created, needs to be part of this availability set. I'm going to fast forward here and continue creating the 2 virtual machines and come back when they're completed. Alright, so we can see both of our virtual machines, SL test AS01 and 02, have been created successfully and are both running. Going to flip over to our availability set now, just by using the search button at the top. Go to availability sets, and we can see SLVM demo AS that we created earlier. We'll go into that one. And now on the right hand side, what we can see are our two virtual machines listed there. They're both managed, and we can also see that we have our two fault domains. So SL test AS01 is in fault domain 0 and update domain 0 as well, and SL test AS02 is in fault domain 1 and update domain 1. Now that's great. So these VMs from an availability standpoint are on separate hardware in Azure's data center. One of the other things that's good to know is how you would associate a load balancer with this availability set. This is one of the other things you're expected to know in the exam. Now I'm not going to cover load balancers in detail now. That's going to be covered in the networking section, but let's go over to a load balancer I've created previously. So I'm going to select load balancers from my menu on the left here. You can see I have a load balancer already there, SLAS LB01. Going to select that one. And in here, you can see we have a section for backend pools. If we click that and go in here, nothing there right now, but I'll go ahead and click Add, give it a name. So in this case, I'm just using SL-pool, and now I can associate it to an availability set. So I select that, I select my availability set. We can see SLVM demo AS with two virtual machines in it. And now I add a target network IP configuration. So I choose that, and now I choose my first target machine, so AS01, choose its network IP, and then do the same again. Now for AS02, its IP, and hit OK. And what's great then is now this backend pool is associated directly with that availability set. So, my traffic's going to come in, get spread out between those two VMs, and those VMs are on separate hosts. So in the event there's a failure, one of the machines will always be up and running, and my application will be serviced. And you can see after a little while that's created, expand it out. You can see our virtual machines and our private IP addresses associated with them, as this is a backend pool. And with that, this concludes our demonstration. Now let's take some time to talk about scale sets, and maybe you've heard the term in the industry, cattle versus pets, and scale sets is really a lot around that. Traditionally, if we wanted to scale up an application, we would add more CPU, memory, disk, etc. But scale sets allow us to essentially scale horizontally. So when we want to scale out our virtual machines, we simply stamp out additional ones to meet the demands, and then scale back in when that seasonal demand is slowed down, for example. If we look at this, we can define virtual machine scale sets in Azure, also known as VMSS. You can use the portal, PowerShell, or the API, and you'll see a demo of that a little bit later on. But you define the number of instances you wish to run, the instance size, etc. Do you want to scale beyond 100 instances? Do you want to use managed disks? You define everything around your instances there, and then we determine if we want to auto scale. So keep that in mind. A lot of people think of scale sets as, oh, do I have to use auto scaling? Well, you don't have to. You can go in there and choose to scale up and down as you want to, but you can auto scale if you wish. And auto scaling really is around setting a minimum and maximum amount of instance sizes. So you could say have a default amount that you start out with that you always have to have, like a minimum of 1, but we want to scale up to maybe 10 as an example. Maybe we go with a minimum of 2 just to ensure we have that availability, as we talked about in availability sets, but then I want to scale up for load as well. We can scale out based on a variety of metrics, and these can be infrastructure or application metrics. And this is really important because Azure ties everything together. We can use things like App Insights to look at the application metrics, say like transactions that are happening on a web server, and scale out based on that. Or we can scale out based on traditional infrastructure metrics like CPU, etc. We can also scale out based on a schedule as well. So if we know that at a certain time of the year, let's say a lot of retailers on Black Friday, for example, need to scale out for demand there. We know on schedule, we don't need to wait for the application to be hit hard. We can already preemptively start scaling out. So schedule-based helps in that instance. And finally, you do need to remember to account for sessions when you scale in. Very often, we always want to create a scale in rule at the same time as we create our scale out rule. So we know when demand goes down, we scale in. But if we've got a lot of users with sessions on specific web servers, they're not going to maintain their session if they scale in. So we need to account for that by using things like Redis cache, etc. when configuring auto scaling in rules. So hopefully you can see now there's just a lot of power in treating scaling in this manner, and we'll see more of that in the subsequent demo here. In this demonstration, we're now going to cover how to create a VM scale set using the Azure portal. So let's head straight over there. In the portal, to begin, simply type in scale at the top of your search bar and choose virtual machine scale sets. Up it comes, and as you can see, I currently have no virtual machine scale sets in my environment. So I'm going to select Add. As you can see, it comes up and asks us for some of the basics for our scale set. First of all, give it a scale set name. So I'm going to call mine SL Scale 01. Choose the operating system disk image. So in my case, I'm going to continue to use the Windows Server 2016 data center images I've been using before. It is possible to use your own custom images. You just need to configure it using PowerShell instead. Go ahead and choose our subscription and resource group. I'm continuing to use the same resource group I've been using throughout these VM demos, our location, and then our username and password for those virtual machines. If we scroll down, now we get the details around the instance specifics. So in my case, I'm saying I want an instance count of 2, and now I need to choose my instance size. So in my case, I'm going to select this and choose a B series. If we scroll all the way down and choose the B2S here, and then I need to decide some other things. Do I want to scale beyond 100 instances? Obviously for this demo, I don't need to do that. And do I want to use managed disks for my virtual machines? I definitely do. Next, we do some IP address and information. So I'm going to do SL public 01. With the configuration out the way, we can now move on to the auto scaling section. So if we choose enabled here, another section expands out. If we scroll down, we can see a few things we need to decide here. So the minimum number of virtual machines, this is important. If we're trying to design for availability as well, we probably want to go with a minimum of 2. That's the minimum that will always be available in the scale set. And then we can say a maximum of 4 in my example, but I can choose to go up to 10, 20, etc. And then we can choose how we want to scale out. So what's the decision criteria for scaling out the VM? Right now, we're just looking at the infrastructure criteria that appears on this page, and we can go by CPU threshold, so 75% as an example. When we get to 75%, we'll add another virtual machine. We set it to increase the number of VMs by 1, but we could immediately say, look, when we get to 75%, go ahead and add 2, which would then put us at our maximum of 4. Then we have the scale in rule. As I mentioned, we want to try to create that always when we create a scale out rule. And in this case, I'm saying at 25% CPU threshold, start to decrease my number of machines by 1. And with all of that configured, just go ahead and click create. And we can see deployment is now in progress, and we'll come back to this once it's completed. Okay, so now we can see that our scale set's successfully been created, SL Scale 01. If we go ahead and select it, and we can go in here, we can see our instance count. If we go down to instances, you can see there both of those are running. And if we open up the scaling section, and we can see in here our various auto scaling rules. And as we mentioned before, we're currently scaling based on an infrastructure metric, but we could, if we wish, add additional profiles, scroll down here, add additional rules, and decide if we want to scale in based on other metrics such as application metrics, etc. And with that, this concludes our demonstration. Alright, so it's time for us to begin our journey down networking, and there's obviously a lot to cover here for the exam. If you look on screen, we've got this network overview image that Microsoft always presents us with, and you can see more on this at the link on the bottom of the screen. I do encourage you to check that out. There's just a ton of documentation Microsoft provides around networking. But if you look at the image on screen, on the left-hand side, we have our on-premises network with options for like an encrypted tunnel, direct connection. Over to the right-hand side, which is our Azure network. And this right-hand side is where we are going to be focused on primarily as we work through this module. And there's all sorts of concepts there, but let's start with the VNet first of all. The VNet is one of the core pieces, and it has a number of capabilities that Microsoft provides for us to utilize with VNets in Azure. And if you look on screen, we've got a boundary there. So we've got our VNet boundary. Inside there, I've got 2 subnets, subnet A, subnet B, and I've got a couple of virtual machines in each one. Each virtual machine has a network interface card that connects it to the subnet, and then by default, these subnets can route to each other because they're in the same VNet. And then if we want to, we can put an NSG, a network security group, which we'll hear more about later, around these to say, okay, I want to filter traffic between them. So this is kind of the core concept of just if I want to put machines out in Azure, VNets are the way to do it. So what are all those capabilities? Let's just kind of summarize them and work through this list. First of all, they are isolated. VNets are isolated from one another unless we choose to connect them to each other. So VNet isolation is very important, particularly in multi-tenant scenarios. They all provide internet access. So if we want to connect these VMs to the internet, we can do that by default unless we choose to restrict that, but that is available for us. They allow us to connect multiple Azure resources, not just virtual machines. We could put cloud services like web apps and other services in there. We can plug them into the same VNet as our virtual machines. Everybody can share that networking boundary if they wish. The VNet connectivity, I kind of mentioned briefly, again, we can chain these if we want to, so we can connect VNets to other ones, and there's various methods to go about doing that connectivity. We can provide on-premises connectivity, so we can allow VNets to route to on-premises, as you saw in that original diagram. We can apply traffic filters via network security groups. That's kind of the shields again that you can see on the screen there. And finally, VNets provide a number of capabilities around routing. So we have default routes available. We can also define user-defined routes. And so we can basically customize this to manipulate it in a way that meets the needs of our organization. If we look at some of the key points, let's just hammer these home. Number one, VNets are a primary building block for Azure networking. So just think of this as the core for everything that we do out in Azure and all the services we want to connect together. It's a private network in Azure based on an address space prefix. And this is something that we define. We create subnets in our VNet with our own IP ranges. So we need to plan for them. We do have to think about things like overlap in address space, much like we would on premises as well. We can choose to bring our own DNS or use Azure provided DNS, and there's more to come on that a little bit later on. And finally, we can choose to connect the network to on-premises or the internet if we wish to. But hopefully this gives you a brief overview. I think if you just understand these 5 points and work through the demos, I think you'll get a lot out of this and see very quickly how easy it is to connect all the pieces of Azure networking together. In this demonstration, we're now going to go about creating a virtual network and a subnet via the portal, and then we will follow that on by creating a series of subnets using PowerShell so we can do things much more quickly. But let's get started in the Azure portal. So to begin with, I've already created a new resource group called SL-Network, and on the left-hand side, I'm going to select Virtual Networks. And as you can see, no networks currently present. So let's go ahead and select Add. And the network blade comes up for creating a new virtual network. And let's give this one a name. So the first one we'll call SL-70-533-portal. Now we aren't going to go too much into address spaces in this course. There's plenty of YouTube videos on subnet, and if you want to go about reading that, but for the purposes of this course, I'm going to create a /23 network for this one. So 10.0.0/23, and then I'm going to create 2 /24 subnets inside that /23. Next thing we need to do is go ahead and select our subscription. So I'm using my pay-as-you-go, choose our resource group. So I'll choose SL-Network, and you can see I'm doing this in North Central US. And now I need to name my subnet. So the first one, you can see it creates a default subnet. I'm going to call this subnet A. And we're going to give it the address range of 10.0.0/24. That's the first /24 inside of our /23 range. And we'll go ahead and click create. You can only create one subnet at this point from the portal. And within probably 30 seconds or so, our network will be created, but we'll speed things up here. And that's created, so we'll hit refresh. And there is our network. So now let's go inside there. And we can see if we scroll down to address space, we've got our 10.0.0/23, and let's go into subnets. And we can see we have subnet A, but let's go ahead and create subnet B. And you can see it's already picked the next /24 for us, so 10.0.10/24. And if you look closely underneath, it's saying our address range is 10.0.10 to 10.0.1.255. So we actually only have 251 usable addresses in there because 5 are reserved for Azure. And we're not going to cover network security groups and route tables yet. We'll come onto those later on. So go ahead and click OK. And that will create our second subnet. It should only take a couple of seconds, and we should have our subnet. So you can see we now have a VNet with 2 subnets, subnet A and subnet B. Alright, so we can do things via the portal, but it can get a little bit cumbersome, particularly when I want to create a lot of subnets. So for that, in this next example, I'm going to use PowerShell instead. And let's start off in Visual Studio Code, where I've already got a PowerShell script ready that I can walk you through. So the top section of the script is just declaring kind of the global pieces I need. So the resource group and the locations. In this case, I'm going to deploy this new virtual network along with its subnets that you'll see shortly into SL-Network, the same resource group I used before, and in the same location, North Central US. The second section, I've got my VNet name and address space. So I'm calling this one SL-7533-VNet-P shells to differentiate it from the portal one. And I'm increasing my address space this time. I'm going to use a /22 because inside of that /22, I'm actually going to create 3 /24s, and there wouldn't be enough space if I just stuck with the /23. Here, the next section, I'm declaring some variables around my subnets just so I don't have to type everything in it with every line. So I've got subnet A name, which is SL-web, and that's the first /24, 10.0.0.0. Then I've got my next /24 for SL-app, which is 10.0.1.0, and then my next one for SL-data, which is 10.0.2.0. Next, I declare a variable, which I'm going to use when I create the VNet itself, and I just call this $subnet. And in this one, I created a new Azure RM virtual network subnet config. And this takes subnet A's name and subnet A's address prefix and adds it there there. So think of this like when I created that VNet in the portal, I associated a subnet with it. This is the first one. If I scroll further down, this is where I actually create my VNet and I include that subnet configuration. So I'm declaring this as a variable because I'm going to use it a little bit later, but the command here is new-azure rm virtual network, followed by the name of the VNet, which again is SL7533-VNet-P shell, which I stored further up, my resource group name, my location, and the address prefix for the VNet as a whole, and then the first subnet I want to create, which I reference with -subnet, $subnets being my variable for that. At this point, the network is created, but now I want to create those additional subnets. So I use these additional commands, which are add Azure RM virtual network subnet config. I reference the virtual network. I then reference my subnet configurations, which is my name, so subnet B name, followed by subnet B's address prefix, and then I run that same command again for subnet C. Following that, I have to do one last task, which is to save the additional subnet configurations. They're only local at that point. They haven't been set against the virtual network. So I simply do a set Azure RM virtual network and specify the VNet, and then that will save the changes that we added when we added the additional subnets. So with all that, let's go over to PowerShell and run this. And I've got it here in my C drive script Skylines network folder, and I'm simply going to type in create. So create vnet.ps1 is the file I've got. Hit enter. And that is now going to go off and do all the hard work for us. So we'll give that about 20 seconds or so here. And that's completed. And then it's added the additional subnets. And now it's saved that config. So if we go over to the Azure portal now, go back into virtual networks and do a refresh, I now see I have this PowerShell version as well. So we'll select this one. And in there, if I go down to subnets, you will see that I have my web, app, and data subnets as well. So hopefully you can really see the flexibility and the ease of use that PowerShell will allow you here. I highly encourage you to get used to it straight away, and you almost certainly will get questions on the exam related to PowerShell commands in this area. All right, it's time to talk about IP addressing in Azure, and it helps to know first of all that it's all provided via DHCP, which is an Azure provided managed service. All addresses are DHCP based in Azure. Addresses are not allocated until the Azure object is created. So it's important just to know that they're not pre-allocated or anything. Once the VM is online, created, then it's kind of gets that reservation. And addresses are not recovered until the object is deallocated from Azure. In addition, it's worth noting that static addresses are just the equivalent of DHCP reservations. It's not like you're going in to the backend and configuring something statically. This is simply a DHCP reservation against your machine, for example. In addition, address prefix comes from VNet and subnet definitions that you probably saw in the previous demonstration, and Azure reserves the first three and the last IP from the pool. This is really, really important. You will probably get questions around usable address space in the exam, so know this because it's super important to know that Azure already takes a bunch of addresses up. And finally, when you think about this, the first address of a /24 is .4 because again, 1, 2, and 3 are reserved by Azure. Let's take a look now at internet access and DNS and how Azure handles that. So for internet access, the first thing is all resources in a virtual network can communicate to the internet by default. The way this happens is the private IP that they're given is source net address translated to a public IP which Azure selects. Outbound connectivity can be restricted via routes, so we could use user-defined routes and redirect the traffic maybe to a network virtual appliance, or perhaps we want to send it back through our internet access through on-premises, or we can use traffic filtering, things like network security groups to restrict access. Finally, if we do want inbound connectivity and we can't use source net address translation, so this is someone coming into us directly from the internet, we haven't made a request out, then we do require a public IP address. But how then do we handle DNS? Well, there's a couple of things that we need to consider. One is Azure provided DNS. So this is the default behavior. Microsoft provides DNS as a complete service to you, so you can resolve all of Azure services. Your VM host names can resolve each other inside the same VNet. And you do have the option also of providing your own DNS server. So this could be something like an infrastructure as a service VM, where you've installed a DNS server on top of that. So it could be Active Directory DNS as an example, or it could be like an Infoblox virtual appliance that you decide you want to deploy out in Azure. Okay, so how do we choose between customer managed DNS or Azure provided DNS? Well, there's a few scenarios that we should cover. The first one being if name resolution is just within the same virtual network, the recommendation is to go to Azure provided DNS. If name resolution between role instances or virtual machines is in different networks, then we should probably think about going to customer managed DNS servers again, whether that's Infoblox or some IaaS type DNS server that you have. Now, when we start to look at on-premises, so if we're trying to resolve on-premises computers and services from role instances or VMs in Azure, we almost certainly want to go to customer managed DNS and then this DNS will propagate throughout our whole network, and we'll be able to resolve host names on premises. And in return, the final scenario, we might have on-premises computers that want to resolve Azure host names. So again, customer managed DNS. And as I mentioned, you can just have your customer managed DNS servers set up a forwarder on them if you need to forward to Azure-based DNS. So how then do we go about configuring DNS? Well, at the VNet level, you simply select a virtual network in Azure, select DNS from the pane on the left-hand side, and by default, it will be on Azure provided. Just change that to custom if you want to choose your own DNS servers, add your DNS servers, preferably more than one, obviously, and select save. And note this piece here, virtual machines within this virtual network must be restarted to utilize the updated DNS server settings. So keep note of that. If you think things aren't working right well, it's probably because you haven't restarted the virtual machine. The other thing to note is that you can also apply this at the individual virtual machine level as well. So you can go there and update the DNS servers for the network card in that aspect too. Alright, in this demonstration we're now going to take a look at the IP address configurations of virtual machines, and more specifically how we can configure a static IP address and also how we associate and disassociate public IP addresses from our virtual machine. So let's head over to the Azure portal. So here in the portal, I've got a new virtual machine called SL-TEST-VM01, and when I built this machine, I had it create the public IP address at the same time. You can already see it there on the right-hand side in the summary screen. If I select Networking, the important thing to note here is that I can attach and detach the network interface card. The network interface card is an individual software-defined networking object that's in Azure. It's a resource in our resource group, and you can see the one that's created here, SL-TEST-VM01917. In addition, you can see I have a public IP associated there, and I also have our private IP associated there as well. And if I wanted to, I could also do network security group rules, which we'll cover later in the module, but those are below. For now, select the network interface card. And then on the left-hand side, select IP configurations. And you'll see our IP config, which is in subnet A. So if I expand this, you can choose subnet A or subnet B. But if we look at the bottom, IP config 1, it's an IPv version 4 address, and we've got the private one, 10.0.0.4, which is dynamic, and we've got our public IP address, which is also an individual resource that we can define. Now, if I select this configuration, I can manipulate everything from the screen. So I could simply disable that public IP address immediately. I can hit disabled, I can re-enable it, and I can also change the public IP address. So I could select this one, and if I wanted to create a new one, I could, or if I wanted to select one of the other ones I already have, I could below. Now, this one isn't available for selection at all, even if I went to another machine, because it is associated with this particular network interface card. But if I close this down and go back to the screen prior, you can also see on the bottom the private IP address settings. So in subnet A, we've got this dynamic assignment of 10.0.0.4, and I can simply change that to static, and I can set that IP address to be permanent on that machine. So you can see there's just a lot of flexibility because you control everything individually at this network interface card level, and all the public IP addresses are separate as well. And it's important for the exam that you know how to get to this point, you know how to disable the public IP address, and you know how to set a private IP address as static. The other thing, just to point out very quickly, if we go back one, we're not going to save any of that. You've also got the DNS servers section on the network interface card as well, and we can choose to inherit our DNS servers from our virtual network, or we can add custom DNS servers as well at this point. And all of this is just a lot of flexibility that you can control individually at the resource level. Let's now take a look at routing inside of Azure, and to begin with, let's look at the system routes. Every subnet that you create has a route table that at a minimum contains the following routes. The local VNet, this is the route for local addresses, and so there's no next hop value. On premises, this is the route for defined on-premises address space that you might have in your main data center in your premises, and the next hop will always be the VNet gateway, which traverses the traffic to your on-premises data center. And finally, you'll have your internet route, and this is a route for all traffic destined to the internet, and the internet gateway is always the next hop address here. The default routing in a subnet is as follows, and if you look at the diagram on the right, it gives you the three major use cases, but we'll break them down a little further. One, if the address is within the VNet address prefix, we just route to the local VNet, so we have implicit routing for VNet addresses. If the address is within the on-premises address prefixes or BGP published routes, we route to the gateway, and this is implicit routing for on-premises address on the left-hand side there. If the address is not part of the VNet or the BGP or LSN routes, we route to the internet via NAT. And then finally, we've got two more. If destination is an Azure data center address and express route public peering is enabled, it is routed to the gateway. Or if the destination is an Azure data center, but we're using site-to-site or an ER express route again without public peering enabled, it is routed to the host NAT for internet path. However, It doesn't actually leave the data center. Going a little further, we can also define user-defined routes. So if we look at this is our typical scenario with system routes that we kind of described before. And you can get more information on this by selecting the link below. But to go a little bit further, let's see what happens if we change something like this, where we have our web servers and our database servers. Currently, they can talk to each other because they're in the same virtual network, so the system route works there between the subnets. But what can we do if we want to route them through, say, a Palo Alto or something like that, or another network virtual appliance? Well, we can input a user-defined route to stipulate that all of the traffic now has to flow through this virtual appliance. And that's effectively what a user-defined route is. We go into the route table section of Azure, we define it, and then we associate it, and we force all the traffic to the appliance. And you'll see that in the upcoming demo. Last but not least, we also have one other trick up our sleeves. When we want to connect one virtual network to another one, we can use something called VNet peering. And what this allows us to do is, say we have the hub of shared infrastructure services on the right-hand side, and that virtual network, we want to be able to route to services in, say, the customer apps VNet or the data services VNet or another VNet. Then we can simply peer the VNets. And that's effectively like joining them together so they can route within that same space. And now, the only problem we might have is if we want to go again, we can't daisy chain to a third one. So we can't, say, do another peer between customer apps VNet and another one beyond that. That won't work. It only works directly between two VNets. So you can't assume that it daisy chains along the line. But that's it for routing and VNet peering. Check out the upcoming demo, and hopefully that will solidify all your knowledge in the space. In this demonstration, we're now going to show you where you go in the Azure portal to configure user-defined routes as well as configure VNet peers. So let's head straight over there. Here in the portal, the first thing we're going to do is show you how to configure the user-defined routes. To do that, simply search from the top for route. And you should see something come up called route tables. Go ahead and select that. Once you're in the route tables, by default, unless you've created any user-defined routes, you won't see anything there. Go ahead and select add. And now give your route table a name. So we'll call ours SL UDR test for my example. Choose your subscription and your resource group. And go ahead and select create. That should take about 20 seconds to deploy, and once completed, you have your route table. So go ahead and select your route table. And now the way we go about doing this is to go to settings and go to routes, and then create our specific route. For example, we might want to connect to a network virtual appliance like a Palo Alto, so we might say SL NVA Palo route. We choose our address prefix for the hop, so we might say 10.0.0/24 for that address prefix, and then we can choose from the next hop type. You won't get an option to choose the IP unless you choose virtual appliance. So you can see there that now I'm able to enter my next hop address. So this could be a hop in a different subnet for that gateway appliance. So 10.0, let's say 5.90, for example. That could be where that appliance sits, and hit OK. And after about 30 seconds or so, that route will get created. Now the routes themselves aren't any use unless you associate them with a subnet. So now that that route's been added, if I just refresh, you can see that route there. It won't actually do anything unless I go into subnets and associate this whole entire route table with my virtual network. So I could select one there and select my subnet as well. So this is just an example for you. I'm not going to do it in this case, but hopefully that shows you that you could design an entire route table and then associate it with multiple virtual networks and subnets that you see fit. Now the second thing we need to do is go back and look at peering. So if we go to virtual networks, and we see we've got our two networks there. Let's see what happens if we try to peer these. To do that, we can go into 7533-portal, scroll down, and you'll see the section called peerings. And go here and select add to add a new peering, and give it a name. But what you'll notice, let's call this SL test for the moment because it's not actually going to work. If we go down to virtual network, choose a virtual network, and you can see there's nothing it can peer with. And the reason for that is that everything there has overlap in address space, which naturally will not work because we won't be able to route to it. So let's cancel out of this. Let's create a new virtual network. We'll go back to virtual networks, select add. We'll call this one SL-70533-peer. And let's give it an address space. Now watch out, if we type in 10.0.2.0/23, it'll actually tell us already when we build in VNets, which is okay. We could, if we wanted to, build lots of VNets with overlap in address space if we didn't want to, but you can see here it does warn us that there's overlap in address space, so I'm not going to use this one. I'm actually going to use 10.04.0/23 3 as well. And other subscriptions, use pay-as-you-go, choose your resource group, and scroll down. I've got to create a default subnet for this one, which I'll just choose the first one, /24. I'll put that in the right box, there we go, and then give it a name. And with that, go ahead and create that VNet. Just refresh, probably take a few seconds, there we go. And now if I go into that VNet, into peer, and I go down to peerings, I can now click add, the name again, and I can choose my virtual network, and you will see that portal and my other VNet, the pshell one, are both available because they do not have overlap in address space. And so we'll just select one of those for now, just to show you the rest of the settings available to you here. You've also got things like allow forwarded traffic, and this basically says that I'm going to allow forwarded traffic from outside of the peered VNet, so traffic that's destined for this virtual network but came from outside the peered VNet. The other two that I've got here is around gateway, so I can allow gateway transit. This allows the peered network to use the gateway in this VNet and essentially use it to traverse maybe to on-premises as an example. And then the other option is use remote gateways. And to use remote gateways, I do have to allow gateway transit. It requires that to be checked, but then allows this network to use the peer's gateway instead. And with that, that's everything you need to know around user-defined routes and peerings. And I'm going to go ahead and close this out, and that's the end of this demo. One of the core security components for networking in Azure are NSGs, also known as network security groups. And what are they? They're essentially a traffic filter, a network filter that's checking traffic. Think of it like a firewall, and it basically allows or restricts traffic to resources in our Azure network. There are two types of rules. There are inbound rules and outbound rules that you'll see in the upcoming flow that we'll walk through. And finally, they can be associated to a subnet or a network interface card, and it's very important, something I'll reinforce over and over throughout the section. Finally, it is worth noting that in classic Azure, you were able to associate NSGs with the virtual machine itself, but that changed under the ARM model, and now you've got the network interface card and the subnet that you can associate with only. Now, if we look at this from a flow perspective, if we've got some virtual machines in subnet B that wish to communicate with virtual machines in subnet A, we ultimately go through this kind of traffic flow. The virtual machine in subnet B wants to communicate with this virtual machine in subnet A, and the traffic goes out through the subnet NSG in this example. And that NSG is going to check it from an outbound rules perspective. If it's all okay there, then the traffic will continue on to subnet A. The NSG in subnet A will check it from an inbound rules perspective, and then if everything's okay, allow it to talk to the virtual machine in subnet A. Now again, this can be applied at the network interface or subnet level, and the subnet rules apply to all the resources in the subnet. Now think about this from a rule precedence perspective. If the NSG is applied to the network interface card and the traffic is coming outbound, it may never even reach the subnet NSG. That network interface card overrules the subnet policy. The same in reverse. If we're coming into the subnet, and let's say the NSG associated with the subnet allows the traffic in, it'll get to the virtual machine, and then the network interface card can still deny it. So just think of it from that perspective. It gets denied, outbound first from the network interface card, then to the NSG on the subnet. If it's reversing coming inbound, the traffic is stopped potentially first at the subnet NSG and then again at the network interface card NSG. Now, what are some of the properties that you configure when you create a network security group? Well, aside from just giving it a name, we have to define these things. One is the protocol that we want to allow. For example, it could be TCP or UDP. Second, the source and destination port range. So anything in the range from 1 to 65,535, or we could simply choose a star for all ports. We have our source and destination address prefixes. So this could be our ranges, or we could use default tags, which I'll come on to shortly. We can do our direction, so inbound or outbound. That's obviously a natural property there, and that, as we went through the flow previously, that's going to determine where things are going to be stopped. The priority, which I'll also come on to in a moment, so that's, in what order are these rules evaluated, and then whether we choose to allow access or deny access based on the rule we've just defined. So we set the criteria, and then at the end we say allow or deny. So what about rule priority that I mentioned? Well, rules are enforced based on priority. As you can see there, they have a range from 100 to 4096, and the lower numbers have the highest priority. So if you've got a rule that's 100, that's going to be a higher priority than a rule that's, lower down the spectrum, closer to the 4096. So hopefully that gives you an idea there. Now, the default tags I mentioned are also really important because they can make things a little bit simpler when we're trying to restrict certain ranges of IP address. And these are system provided to identify groups of IP addresses that Azure has provided for you. And there are three major ones that you need to deal with. First of all is your virtual network. So this includes all the CIDR ranges defined in Azure for virtual networks. In addition, you've got your Azure Load Balancer. This is Microsoft Azure's infrastructure load balancer, i.e. this is an Azure data center IP address. And finally, we have internet. So this is all Azure space outside and reachable by the public internet. And this includes all of the Azure-owned public IP space. Now, if you're still unsure what these are for, just remember when we create our rules, we can choose to use service tags instead. So rather than us having to try and figure out all these IPs that we want to deny in these services where there's groups and groups of IPs, we can simply use the default tag instead. And this just makes it a lot easier for us to say, okay, I don't want to allow any traffic to Azure Load Balancer, well, I can use a default tag for that. Now, when we look at the NSGs and we've created one, there are a number of default rules that are created as well. And we've got the inbound and outbound rules on screen for you. And they essentially are the same if you look at the categories across them. So if we look at the top row in both inbound and outbound, which is called allow VNet inbound and allow VNet outbound, this is for traffic originating and ending in a virtual network. And this is allowed for both inbound and outbound directions, as you can see there. Then you have internet on the bottom there. This is allowed by default out, but is blocked coming in. And finally, in the middle row there, we have our Azure Load Balancer, and this allows the Load Balancer to probe the health of your VMs and role instances. Now, you can change these rules, but you can't delete them. They have to be there in the network security group. By default, what you will notice is that the priorities are very, very low. So they're not set to a high priority. A lot of the rules you create will be given a higher precedence over these ones. One final thing we just need to cover on networking is around networking limits, and you can see the limits on screen. You can get the latest limits by checking on the Azure website. Now there's a couple I'll just bring your attention to. For one, there's a default limit for network security groups of 100, but this can be increased very easily to 400. NSG rules per an NSG, we're looking at a default of 200, but this can be increased to 500. But the other ones I'll bring your attention to are public IP addresses, which for dynamic ones you can have 60, for reserved public IP addresses 20, and to actually get those increased you have to contact support, and they don't like to increase those very easily. So that's just something to be aware of there as you're thinking through some of your network configurations. In this demonstration, we're now going to create and configure a network security group in the Azure portal. So let's head over there. In the portal, to create our network security group, simply select Create a Resource, select from the Networking section, scroll down, and you will see Network Security Group. Select that, and give your network security group a name. In my case, I'm just calling it SL-NSG. I'm using a pay-as-you-go subscription, and I'm going to put this in our network resource group that we've been utilizing. Go ahead and click Create. This simply creates the shell, if you will, for the network security group. Takes about 10 or 15 seconds. And once completed, we'll go to that resource so we can begin configuring it. So as I mentioned in the tutorials, there's a number of default rules. So you can see them there, the inbound security rules and outbound security rules. But we're going to go ahead and create a new inbound security rule. Let's say we want to deny RDP traffic to a specific subnet. So we would go into inbound security rules. And in there, we click Add. And now we get all of our options. So first of all, we can choose our source. This could be any, could be a specific IP address, or could be one of those default tags we described. I'll just show you that for the moment. If we look at the default tags, we can choose Internet, Virtual Network, Azure Load Balancer, as well as other specific services available in Azure. But if we go ahead and select any, and we'll choose the port range. So in our case, any port could be the originator. The destination could be any, and we're going to say for port 3389, which is the port for RDP over any protocol, deny. And here we can now choose the priority for the rule. So in this case, 100, this is the highest priority. It's going to override everything else. We can give it a name or just accept the default one that's provided to us. If we select OK, this creates the inbound security rule, takes a couple of seconds, and that will appear in your network security group. The next thing we need to do while it's creating that is decide where we want to associate this. So for example, we could associate it with a network interface, and we can go in there, select Associate, and choose one of the network interfaces that's available to us on perhaps one of our virtual machines. Now, as you can see in this example, all of our virtual machines, their network interface cards are already associated with NSGs that were created when they were built, so they're all grayed out. But now maybe I want to associate it with the subnet, so I can select the subnet, choose Associate, and now I select the virtual network first of all. In this case, I'm going to use the only one I've got created currently, followed by my subnet. I'm going to choose subnet A, select OK. And now any traffic destined for subnet A on ports 3389 will be denied. Now, it's very important to remember the precedence of rules associated with NSGs. So inbound traffic coming into that subnet could get denied by the network security group that we created there that's associated with the subnet. Now, perhaps it gets allowed through. We don't have that deny rule for 3389, but we have another network security group associated with the network interface card on the VM. It can further get denied at that level. And in reverse, when we're going outbound, we could have outbound rules attached to the network interface that deny all traffic before it even gets to the subnet rule. And then when it gets to the subnet rule again, we could have an NSG there that's denying traffic or allowing traffic out. So just remember the rule precedence there, especially for the exam. And with that, this concludes this demonstration. All right, so everything we've been talking about so far has been primarily focused around the Azure virtual networks and all the great software-defined networking services that we can build out there. But often we still want to connect that Azure network to our on-premises data center. And so we have a number of hybrid connectivity options available to us from Microsoft. First one, and very common, is site-to-site VPN. This is how a lot of people get going before they're ready to commit to something larger. And essentially this involves connecting your data center over a VPN device to Azure. The next one is ExpressRoute, which is kind of what people mature and gravitate towards as they adopt a lot of Azure and decide, okay, I'm ready for a dedicated circuit. Maybe I'm doing a large scale migration. Maybe I've got a lot of data to access on premises and in the public cloud, and I've got apps running everywhere. I really want Azure to feel like a permanent extension of my data center, and ExpressRoute is a good method for that. And the third one is point-to-site, which is a very easy way to connect, say, your laptop directly into a virtual network. And we're going to cover all of these in a little bit more detail as we go through the module. So let's begin with site-to-site VPN, and you can see a couple of examples on screen right now, but let's just take a look at the top one first of all and focus on the basics of a site-to-site VPN. Well, on the one side we have our data center, in this case on premises. It's got its own IP range, and on the other side we have Azure with a VPN gateway. And essentially we just want to connect these two together. We have to have a public IP on the right hand side. You can see there we've got that VPN VIP, and on the right hand side we've got our VPN VIP there. And what we do then is we create an IPsec IKE S2S VPN tunnel between the two, and now they are connected. Now we can also do this across multiple sites, as I mentioned, so we could have multiple data centers with their own networks. Again, you can see in a lot of these examples we don't have any overlap in address space because that's obviously not going to work from a routing perspective, but multiple sites all connected in to the same VPN gateway. So there's a lot of flexibility there. If you've got a lot of offices or a lot of data centers that you want to connect in, you can do it that way. You could also create multiple VPN VIPs if you want to connect different offices into different VPN gateways and segments of Azure networks. You can really start to carve this out in multiple ways. If we look at some of those specifics, you definitely need to know for the exam, a site-to-site VPN gateway connection is a connection over IPsec/IKE. That's IKE version 1 or version 2. It requires a VPN device in your enterprise data center that has a public IP address assigned to it. It cannot be located behind a NAT, and site-to-site connections can be used for cross-premises and hybrid configurations. If you definitely take one thing away, remember those 4 points for the exam. If we look at point-to-site, then in contrast, this is really about connecting clients directly into the network. So you can see on screen there we have a number of VPN client users, on the right hand side, and they could be a mixture of laptop, remote workers, could be people at their desks, but essentially they've got a few options there. They can do an SSTP or IKE version 2 tunnel, as you see on the screen there, into the VPN gateway. Now that's just like VPNing into your corporate network. When you want to access network resources in your corporate network, you might VPN in there. Well, same thing here, you're just VPNing into Azure, and now you have access to your resources in the Azure network. The one thing I will say about this, a lot of people use this in conjunction with, say, a jump box. So you might VPN in, connect to a jump box, run it from there, or potentially look at some of the new services like Citrix and Microsoft's RDMI and things like that that are coming out. There's a lot of ways to kind of solve these scenarios. And I'll bring that up because there's a few things you definitely need to know, especially for the exam here. Obviously, we understand it's a secure connection from an individual computer, and it's great for remote worker situations. There's no need for a VPN device or a public IP. We can connect wherever we have an internet connection. OS support is something we have to consider, so it's all Windows support primarily at the moment. Throughput and scale is the big thing, though, that we have to be concerned about. Throughput's up to 100 megabits per second, and this is unpredictable due to the internet, and it just doesn't scale easily. This is difficult to manage. It's really only useful for a few workstations that you might want to connect in this manner. Now, in addition, you also need to know about the different VPN gateway SKUs that are available to you. So if you look at the bottom there, starting with the basic SKU, it has a maximum of 10 tunnels available. For the point-to-site connections, it's 128 across all of the SKUs. But the other big difference, if you look at the basic one, it really has a maximum throughput of 100 megabits a second, so that's not very much. You really have to get into VPN gateway 1, 2, or 3, where they start at 650 meg, going up to 1 gigabits a second on VPN gateway 2, 1.25 on VPN gateway 3, and those gateways allow for the max of 30 tunnels, so a lot more flexibility. If you look at it from a recommendation standpoint, pretty much if it's a production critical workload, you're not going to use the basic. You're just going to pick the VPN gateway SKU that meets your throughput requirements. If it's dev test or proof of concept, then sure, the basic SKU is fine. And then at the bottom there, you can also see we've got the SKU, whether it's basic or the VPN gateways, and just the features on the right-hand side. So if you see a few things there on the basic SKU, policy-based VPN does not support point-to-site. I already mentioned it's kind of 10 tunnels maximum. When we're looking at route-based VPN, the policy-based is only 1 tunnel. And then if we look at the VPN gateway SKUs, again, up to 30 tunnels. Point-to-site, BGP is supported, so that's the Border Gateway Protocol for routing, and you've also got custom IPsec, IKE policies, Express Route VPN can coexist, so we could have like an Express Route connection with a VPN failover as well. So that's kind of just a summary of your gateway recommendations there. Now, if we want something a little bit more dedicated, a little bit more private, better guaranteed throughput, we can move up to something like ExpressRoute. And this essentially is a dedicated circuit between us and Microsoft Azure, and it works in a number of steps. So first of all, we have our network on the left-hand side. We're going to choose a partner to work with who's going to provide that connection all the way across to the Microsoft Edge. And then we have the flexibility of looking at the private services or the public services available to us in Azure. And that's really important. If we look at the private services, this allows us to connect directly to anything we've created like VNets, etc. in Azure. The public services, in contrast, this is things like Office 365, as well as services like blob storage, PAS SQL services, Power BI, etc. These are kind of those services that are publicly exposed in a public address space, and we can choose to have those connected to our circuit, if we want to or not. Now, in addition, you've got some connectivity models that you need to choose between. There's 3 major ones available. One, very common now, is a lot of people started to use these cloud exchanges in a colo location. That could be like an Equinix facility as an example, and they will provide the cloud exchange for you and connect you into Microsoft Azure. We could do a dedicated point-to-point Ethernet connection that could be set up with our partner, and they would help facilitate that. Or we could do something like an any-to-any IP VPN connection over a MPLS WAN type scenario. If we look at the key benefits of ExpressRoute, and there are definitely many here, but let's just hit on some of the main ones. Well, first of all, this is now providing layer 3 connectivity between our on-premises network and Microsoft Azure's network. So it adds a lot of flexibility in allowing us to share resources between the 2 data centers. It allows connectivity in all regions, so to every Microsoft Cloud service across all regions in the geopolitical region. But in addition, you can add on ExpressRoute Premium add-on, and this allows to Microsoft services across all regions with that add-on, so global connectivity at that point. In addition, we've got dynamic routing, so this uses BGP, so this is the industry standard protocol. So between our network and Microsoft, we have that all built in, and there's built-in redundancy. So in every peering location, Microsoft is ensuring redundancy of hardware at every single point along the way, so we don't need to worry about that in addition. Okay, so you've decided you want to move up to ExpressRoute, but what does it take to get all of this provisioned? Well, there is a bit of a process, and it can take many months sometimes for this to be completed. This isn't as simple as just going into Azure and clicking new service and it's up and running. There's data center work that has to be done. And so there is a workflow. Let's just kind of walk through that. First of all, ensure your prerequisites are met. So you need to have a connectivity provider identified and set up a business relationship with them. Make sure you have your Azure subscription, and you have to set up physical connectivity with your provider as well. Then you go about ordering your ExpressRoute circuit. You're going to select things like your peering location, your bandwidth, your billing model, and whether or not using the standard or the premium SKU. Next, the service provider is going to provision that connectivity. You're going to provide them with some information. There's a service key you have to give them. They're going to provide you with information and get that connected. You'll work together to establish that connection. And then you can start using your ExpressRoute circuit, and you can link your VNets to Azure private peering. You can link to public peering. All of that suddenly becomes available to you. Now, in addition, it's worth noting some of the data that you have to collect. And some things are very, very important, because for private peering, public peering, and Microsoft peering, you're going to have to create some /30 subnets for your path. So for path 1 is a /30, and for path 2 is a /30. That's for private peering. For public peering, it's the same, but you must have a public IP, and same for Microsoft peering as well. So these are pieces of information you have to have on hand in order to be able to establish that circuit. And now it's very important just to know about the /30. Often in the exam, you'll get some questions around space and subnetting, and just knowing around, that those require /30s is very, very important. If we kind of look at one other aspect of this, there's the concept of unlimited versus metered. So if we look at unlimited, first of all, speeds from 50 megabits a second to 10 gigabits a second, you have unlimited inbound data transfer, unlimited outbound data transfer, but you do pay a higher monthly fee for this unlimited option. Now, naturally, if you look at the metered option, well, you still got the same speeds. So you can go from 50 to 10 gigabits a second. You've still got unlimited inbound data transfer, but the big difference is the outbound data transfer is charged at a predetermined rate for gigabyte. Now, there's a lower monthly fee for that, obviously, because you're sacrificing that outbound unlimited data transfer. And, obviously there, if you bring in data in and you're just moving into Azure, metered may be the way to go. But if you foresee a lot of traffic going both ways and just watch for questions on this, then, the unlimited option would be better for you. So to end off, let's just take a look at some of the express route considerations. There's three major areas. One, just understand the model. So the difference between unlimited data and metered data. If you're trying to do this in your own data center, understand what model you're using today to accelerate adoption, understand the differences in port speeds, locations, and approach, things like that. Understand the providers and what they offer. And finally, understand the costs. If you think of these three things, models, providers, costs, you'll be well on your way to, being able to answer any of the express route questions they might throw at you. And with that, this ends this module. Hopefully this gives you a good background on everything you need to know from a connectivity standpoint. Like I said in the exam, the questions will be focused around you picking probably the right SKUs around the VPN gateway, so definitely know those, choosing between express route connection versus site to site, when to use point to site, things like that are likely to come up. And with that, that's the end. Thank you. In this demonstration, we're now going to take a look at Network Watcher. So to begin with, let's head over to the Azure portal. Okay, and here we are on the Azure portal, and the first thing I've done, I'm just showing you that I've deployed 3 virtual machines already. I've got VM test 01, 02, and 03, and they're all in the resource group SL-Network Watcher, which I've already created. Now, one thing to note, first of all, in order to use Network Watcher, you do have to install a Network Watcher agent in the machines that you might want to use the connection monitor feature with. So as an example, if I go to VM test 02 and scroll down on the left-hand side, you'll see the section called extensions, which if you did the AZ100 exam or other Azure training, you will probably be aware of. And this is where you can add different extensions, agents, chef agents, things like that. But one in particular is that Network Watcher extension. You can see it's already installed on this one, and this is a Windows machine. If I go over to VM test 03, this is a Linux machine where we've also installed, then you can see it's operating system Linux here. And if we go to extensions, and you can see again the Network Watcher agent is there. But just to show you how to install that, I'm going to go to test 01 where I haven't installed it yet. This is also a Windows machine. And we'll go down to extensions, click add, scroll down the left hand side, and you will see Network Watcher agent for Windows. And when you're building your virtual machines for the first time, you can also do it during provisioning. But we'll click Network Watcher agent for Windows, click create on the right hand side, click OK. And you can see it's initializing that deployment, and it's now deploying that agent. So it's logging into the machine and actually setting up that agent service to run inside the machine. So at this point, we can come out of the virtual machines, and let's focus now on Network Watcher itself. To access it, click All Services, type in Network Watcher, and you'll see it there. It's probably worth favoriting it because you'll probably come back to it periodically. Click Network Watcher, and this takes you into the Network Watcher overview section first of all. Now on the right, you'll see your subscriptions, and you'll see the regions that are supported by those subscriptions. In my case, I've got Skylines Primary is the one I want to use. If I expand this out, I can see the regions and whether Network Watcher is enabled or not in that particular region. So I've deployed these machines in North Central. I've already actually enabled Network Watcher in that region. Let's say I had deployed them in South Central. Well, I would just go over to South Central US, click these 3 little dots on the right for the context menu, and click Enable Network Watcher, and that will deploy the Network Watcher to that specific region as well. So just be aware of that. That's how you enable it. And you may get some questions on this on the exam itself. So with those enabled, let's take a look first of all at the topology view. So I can click this. This is under the monitoring section, choose my subscription, Skylines Primary, select my resource group, SL Network Watcher, and immediately it will actually load up and show me, okay, I've got my VNet, my subnet, I've got 3 network interfaces in there, and those are the network interfaces associated with those 3 VMs respectively. So it's quite a nice way to just get a viewpoint of what's going on in your environment, and you can also download that topology if you want to as well. Next, we'll take a look at Connection Monitor. So let's click Connection Monitor on the left-hand side. And what we can do with Connection Monitor is basically track the connection between, say, 2 of our virtual machines for latency, can they reach each other, etc. So we click the Add button here to create a new monitor. And we'll say from VM Test 02 to VM Test 03. And we choose our subscription and the virtual machine. So we'll choose VM Test 02. and our target machine, VM test 03, and we'll say port 22, which is our SSH port that we want to connect over. Again, we're connecting from the Windows machine to the Linux machine. We'll click Add at this point, and that will set up the connection monitor for us. Okay, and after a little while, that should complete. If you don't see it, just change the subscription to the one you created the monitor in, and then it should show up for you there. And here you can see the monitor, and if you click the context menu, you can start, stop, or delete that monitor from there. Now, to get the details, you need to click this details pane on the bottom, expand it out, and you might just need to move it up ever so slightly. Then you can scroll down, and now you can see details from that monitor. So we can see, if we scroll down, average round trip time, 1 millisecond, so we know everything's working great there. No probes have failed at this point. We can also get some more information, so we can see that VM test 02 is connected on 10.0.0.5. Its next hop IP address to reach that machine is 10.0.0.6, which is actually the IP of VM test 03. If we scroll back up as well, you could get metrics on this. You can see the graph. You can sort of change the time, look at the data. And if you scroll down again, you can also create a topology view to kind of look at the connection between those two machines. So in this case, nothing big there. VM test 02 is going to basically, as its next hop, go into that VNet, which VM test 03 is in, and it's basically going to connect over 10.0.0.6. So just a great, area for just monitoring connections between machines and just checking the overall health of them as well. So now we've covered connection monitor. Let's scroll back over to the left. You'll notice you now have a link for network performance monitor. They recently added this. We're not going to cover details of NPM in this course. We sort of mentioned it in the lecture section, so you need to know what all the NPM monitors are for, but this is where you would add your NPM monitors that are as part of your log analytics workspace at this point. What you do need to know, however, is these things around IP flow verify, next hop, and security group view. So if we start with IP flow verify, this is a way to check if a packet is allowed or denied from a virtual machine. So again, we can sort of go in here, choose our subscription, pick our resource groups, already got it there, SL Network Watcher, pick our virtual machine. We'll take VM test 01 at this point. It'll automatically select this interface once you've selected the virtual machine, and say, okay, well, what about an outbound flow? So let's say we want to go from VM test 01. Let's say we want to ping the Bing address as an example. Let's go ahead and type the information in for that. So local port will have 60,000. We'll just put just a random local port there. And for our remote address, this is the Bing IP, which is 13.107.21.200. You could use any favorite website that you have there. And remote port, we know this is going to be on port 80, which is the web port that we want to check against. And at this point, we click check. It'll take a second. If you scroll down, you'll see it says load in. And a minute later, maybe not even, you'll be able to scroll down even further. There we go, it's actually already done. And you can see access allowed, and the security rule it's allowing that is the allow internet outbound rule. So very simple way to kind of check things, are working from a connectivity standpoint. And if it's denied, it's going to tell you which rule basically denies it. And at that point, I'm just going to hop over to security group view, click OK to, we don't need to save anything there. And basically same concept. I can click in here, click say Skylight's primary, choose my resource group, choose my network interface. Go select our virtual machine first of all. So we'll click VM test 01, choose that network interface, and same thing here. You're going to get a list of all the effective rules that are in effect for that particular network interface and where they're coming from. You could, if you want, isolate them down by subnet rules and network interface rules. So you can see there, these are the network interface rules, these are the subnet rules, but these are the, ultimately the effective rules themselves. And you can click in on one of these rules if you want to, like deny internet outbound. With any additional information, it would be there. If we scroll to the right-hand side, you can also see the protocol and whether it's denied or allowed here as well. So just a overall viewpoint, instead of going back into the NSG to kind of look at things one at a time, you can just come in here, select the interface you want, and download this rule set if you want to as well. Last but not least, next hop is quite useful as well. You actually get some of this from that connection monitor that you may have seen earlier on. But same thing here, I can click my subscription. I've got my resource group there. I've got my machine, you go VM test 01 again. I've got my network interface, source IP address, and let's say, you know, that next destination, let's say it was the Bing server again. This just tells you what the next hop will be for that particular, you know, website or whatever IP you're trying to get to. So we click next hop after typing that in. It won't take too long, just probably about 10 seconds again, just like before. And as soon as that's done, you can see a result, next hop type internet, IP address doesn't really have one there, it's going straight out to the internet itself. Now, if we do 10.0.0.5, which is one of the other machines in that subnet, click next hop, you'll notice again, we're not going to have a next hop specific IP because it's a machine that's in the same VNet, so you should get a virtual network as your next hop. Next hop type, yep, virtual network, no specific IP there, and you can see this is coming from the route table, the system route, the built-in routes that exist in the subnet, you know, itself. Now, if we had something like a Palo Alto or a checkpoint firewall, and we'd put user-defined routes in that were redirecting the traffic through a firewall like an IDS IPS device, then we would see that IP address there because we've redirected the traffic into that IP, and then the rule sets would be applied on one of those network virtual appliances. A few other quick things just so to round out the knowledge there. We've got VPN troubleshoot itself. If we're trying to troubleshoot any site-to-site VPN type connections, we can basically do that here. We've got packet capture as well. This is quite useful. You click add, and essentially you can do the same thing. You can select the resource group. We'll select our subscription first. Choose the resource group, choose the machine, give it a test capture. Basically what it will do is capture, whether you want it maximum or minimum is up to you, and how long you want to capture for and any filters you want to put on. But this is essentially a packet capture that will output as a .cap file and store that in the storage account for you. Probably won't get asked anything on the exam around packet capturing, just know that this is where you would go to do it. And then we also have connection troubleshoot as well. Similar, framework area, you've got your subscription, resource group, VM, destination, but here is your probe settings that you would basically put in place. So for a destination port, a specific one, you could use this also as a way to kind of check a TCP connection from a VM to either an FQDN or another IPv4 address. But somewhat redundant in some cases to some of the other checks you've got there. It just depends what you're trying to do. For connection monitor, you do have to have, again, those agents running on both those machines. Some of the other services you don't, basically. So just try to understand what it is you're trying to achieve. If you're trying to monitor the connection between two machines, connection monitor is where you want to go. If you're trying to understand if traffic is allowed and what might be denying it, IP flow verifier is where you would go. If you're just trying to figure out, okay, what's the next hop, what has it got to go to next, the next hop view would be where you'd want to go. And then these others kind of support you as well for other specific things like packet captures, VPN troubleshooting, etc. So just definitely know for the exam the type of diagnostic tool or monitor you would basically use, because those are the kinds of questions you're likely to see out there. And with that, this concludes this demonstration.